This set of videos on lecture 4 is also about functions. We'll be looking at two specific aspects of functions, that is parameters and overloading. Almost all of this works exactly like in Java. The one difference is that in C++ we can have two ways of setting up functions and how we pass parameters. There's only one way to do it in Java and C, and actually Java and C. C++ has one additional way. Okay, so there's one way of passing parameters that we have not seen in Java. Apart from that, pretty much everything is the same. Okay, so what is the difference? The difference is call by reference. If you want to get a rough idea or a simple look at this, everything that we did in Java was call by value. If you're used to C programming, everything we did in C was really call by value, although we do refer to some things as call by reference. They are not really call by reference. Everything is call by value, and we'll see what these things mean as we get into the details. Overloading and default arguments work pretty much like in Java. Well, the one thing is in Java we don't have default values for arguments, so that is new in C++. We have asserts, but the assert is a keyword in Java, but it's a macro in C++. Besides that, it's the same idea. So we use it for the same kinds of reasons, for testing and debugging. Okay, so for a quick overview, most of this is same in Java. Difference is C++ has an additional thing called call by reference. It can assign default values to arguments. Okay, so let's take a look at parameters first. There's two main ways of passing arguments as parameters. One is call by value, which we've actually seen in Java. That's what we normally assume is done with parameters in a method. What we do, if you haven't looked at this in very much detail, when we call a function, we copy the value of whatever it is we're sending as argument. So whatever argument we have, we're passing the value of it into a function. Call by reference is different in that what you're going to get is the address of the actual argument, and so you can, inside a function in C++ only, you can actually change the values of things that you called with. So this is very different from Java and C. So call by value, you pass a copy of an actual argument passed. Let's take a simple example. I'm going to show you both right away so that you can see the difference. The difference is not in the way you call a function, although you might think that just because of the name of it. The difference is in the way you set up the function itself. This is how we normally set up a function. This is a simple function, takes two instance parameters and returns an int. We try to sort of change the parameters, but we know that when you pass in something, like when you call this function named by value with two values, the calling function does not see any change in what is passed in. So for example, I have two variables, int x set equal to 100 and int y set equal to 200, and then I call this function by value with x, and so what we do is we pass in the value 100 into this x over here, and even though we increment it, we know that when we print out x after this function returns, x will still be 100. Okay, so that's how call by value works, and that's how Java uses call by value, and that's what we mean by call by value in C as well. And C++ has the same thing. But in addition, this is something that you've never seen in Java, and you cannot do this in Java. You can have an ampersand here to mean that you're passing a reference. And you can think of this as passing a pointer to x so that in this function, if you do an x plus plus or an y minus minus, what you're changing is the value that you passed in, so that now, let me just show you where I call by reference. When I use this by reference function, x and y will be changed by calling this function. Now, most of the time, this is not a desirable thing because these can be viewed as what are called side effects. Technically, that's the term. That is, you call a function with x and y, you don't expect x and y, the values of x and y, to change. And that's how we are used to thinking of parameters in Java. In C++, you have to consider, well, exactly how does this function declare these variables? Do you see this ampersand? And if you do, then even though you're just calling a function, it looks just like this. These two things look very similar, just looking at the way they're called. But this one can change the value of x and y in main. Whereas when you use a by value function, we are used to the usual thing. Even if you try to change things inside the function, we know that back in the calling method, x and y are not changed. Okay. So that's the difference. Call by value, call by reference. And of course, you can do anything you want over here. You can do plus plus minus minus equals divides everything, all of that stuff. So this is just a simple example to show you the basic idea. Okay, so call by value. Once again, you take a copy of the actual argument. You make a copy, and then you put that copy inside the function as a local variable, so that if you change the value of the local variable, it's not copied back to the calling function. So if you modify the local variable, only the local copy changes, and the function has no access to the actual thing from, in this case, main. Okay. So this is the default way of passing parameters, used in pretty much all examples thus far. Everything that we saw in Java used this way of passing parameters. And I don't think I need to go over this. I'm going to skip this example that's in the book. You might want to take a look at it if you're not sure. There are some common pitfalls to try to avoid. One thing would be if you try to declare something that's already a parameter. For example, minutes worked is a parameter. If you try to declare it again as a local variable, you'll get an error message. Something saying you're trying to redefine something that already exists. Okay, so you don't want to do that. And you've probably seen this from Java. Java programmers, you guys know this already. So value arguments are like local variables. And it's just that the functions get them automatically. So it's like there is a declaration up at the top saying there is an int hours worked, which is assigned the value whatever is passed in from the calling function. So they are just like local variables, and that's usually how they are referred to. Call by reference is quite a bit different. This is used to provide access to the caller's actual variables, whatever type that is. So once again, remember, callers, the data can be modified by the function. So when you call a function, you don't expect the parameters. Usually by call by value, if that's the way you expect parameters to work, well, you'll be surprised by call by reference in that the things that you pass in as parameters can be modified inside the function, and those changes will be reflected in when you return from the function. You don't expect call by value to work like that, and it doesn't. But call by reference, yeah. Typically, this is used for some input function to retrieve data for the caller. So let's say you pass in a parameter, and then you ask, let's say, the user, please enter a number for this value. You assign it to that parameter, and then when you return, that data is sort of given to the caller. Okay, so changes that you make inside the function will propagate back to the caller, to the calling function. The way you do this is the only difference is really this ampersand operator after each type in the list of parameters. So for example, we had in our program, we had two parameters, we just happen to have two. You can mix and match. You can say int x is called by reference, this is called by value. You can certainly do that. And if you change it, you don't get any error messages or anything. Everything else still works. I'm just going to compile it to make doubly sure. No error messages. Okay, good. And then let me see if I can run this. Okay, so this time around, x is changed, y is not changed. Okay. So I have two ways of calling this function. First is called by value. Initial values of x and y are 100 and 200. And we print it out. Initial values are 100 and 200 as we assign them. And we call this function call by value. And then we print out x and y again. They're not changed. When you call by value, of course, when you pass parameters, the function cannot change the parameters. And by value, all it does is decrement y, increment x, and then add them. Of course, you'll just get the original value, the sum of the original values of x and y, because we're decrementing and incrementing. All right. The difference in call by reference is that you pass in 100 for x, 200 for y. We bump up x here inside this function. And then when you print out x and y, unlike in the previous case, you see that x is bumped up. Okay. We did take out the ampersand here, and we noticed that we can call by value in the same function. When you say call by reference, it's not really anything to do with the method or the function itself. It's how you set up the parameters right here. If you use an ampersand, then you're using call by reference. If you don't use an ampersand, you're using call by value. Okay, and you can mix and match. Okay, so once again, call by reference. Caller's data can be modified by the called functions used to get input data from, let's say, the user, and specified by the ampersand after the type. And there's an example here. You can look in the book. This is example 4-2, chapter 4. Might want to take a look. Okay, so let's take a quick look at how this is accomplished. What's really passed in? Turns out what you're passing in is a reference back to the caller's actual argument. That is, it refers to the memory location of whatever you're passing in. So for example, in this case, if you have an ampersand here, what you're really passing in is a pointer to x. And what are pointers? Well, we'll get into all of that in more detail later, but for now you just want to be aware that when you call by reference, you're not really just passing a value x, you're passing in something else. That is the memory location of x. And so then when you increment x here, you're actually incrementing this x over here. And it's something that we do not have in Java. So once again, it refers to the actual memory location of the argument. And so this is also called the memory address, which is a unique number referring to a distinct place in memory. That is RAM, or your RAM for your system. Okay. We can have consts in our reference parameter list, and remember that we've used it in the regular parameters, but you can also use it as consts here. Okay, so it makes arguments read-only. All right, so why would you do this? Just for efficiency. There's no other reason. Next up, we'll take a look at some more parameters and other terms having to do with arguments.